I don't think there's any need to wait any longer, so I'm going to introduce our first speaker, who actually previously taught at King's not that long ago. So there might even be people in the room who you taught, Tommy. I don't actually know if that's the case.
We'll find
out. But he's perhaps best known these days as the director of AI in Games. You may have heard his voice on many YouTube channels and podcasts and things like that. And I'm really excited that he's going to open today's Next Level event. So I'll hand over to Tommy Thompson.
Okie dokie. Mike, thanks very much. That was a wonderful introduction. It also cuts down half my intro slides. Could I ask that we try and dim the lights a little bit here so that everyone can see those slides a little bit clearer, because they are quite dark. But yeah, I'll quickly go through the introduction. I'm Dr. Tommy Thompson. I am the founder and director of AI in Games, a company that specializes in providing consultancy and training for companies in the games industry and related tech sectors interested in AI, but also actually working on projects helping either in a programming or a design capacity in a variety of games, or actually doing a lot of communication, which seems to be the bulk of what I'm doing. And as Mike says, the world at large knows me as a content creator, which when you're in your 40s, you're like, oh, really? I had such higher aspirations for myself. I think that's a generational thing. If you're a millennial, you're like, oh God, really? But if you're younger than that, like, bro, the dream. Anyway, so for 10 years, I was running AI in Games as a YouTube channel, and then that eventually spun off into a business. And so I continue to do that each and every month. There's a new video coming out next week. And I also now run a Substack newsletter digging into the realities of AI in the games industry and beyond. So don't forget to like and subscribe, I guess. And in 2024, I made this push to try and build something more sustainable for the community as a whole. And so with a group of wonderful people, we have actually put together the AI in Games conference, the very first one of its kind. It is the first event dedicated to AI professionals in the games industry in Europe since 2017. Very excited, actually. We're running it in just 2 weeks' time. And we have speakers from Sony PlayStation, Microsoft Research, Electronic Arts, Saber Interactive, Guerrilla Games, Unity Technologies, Epic Games, Build a Rocket Boy, Queen Mary University of London, University of Hertfordshire, and more. But tickets are actually sold out, so plugging this is a really bad idea. But the talks are being recorded. They will be available in early 2025. And also, I'm moving towards creating online resources. And in fact, I'm running a Kickstarter next month for an online course series called Goal State, which I'll plug again at the end of the talk. My career makes no sense. Let's not get into that. The key thing, as Mike points out, I used to work here. Any informatics KCL students here? Just show of hands, anyone? All right. Can anyone confirm to me they still use my videos in the Intro to AI class in year 2, or did they finally record over them? Did you? Thank goodness. But we still use the material. You still use them in theory. It's been 2 years, man. 2.5 years. Anyway, so AI for games. When we talk about AI for games, it's often poorly understood. I think AI as a whole is poorly understood. I think game development is equally misunderstood. And you'll have a lot of people on the internet tell you either explained it wrong or they could have done it better. It's got a very long history. And so really when we talk about AI for games, I often start here, because who doesn't love a good taxonomy, explaining it on a high level? Don't worry, we're coming back to this on several occasions throughout this talk. The truth is that AI is a complex, multifaceted discipline of field of study. There are different disciplines, each with a number of unique methodologies, technologies, and application areas. And for the past decade, this has transformed massively. But I think it's always important to start here, because to 90% of the games industry, when you say AI for games, that's what we're talking about. We are using symbolic, traditional classical AI methods for non-player characters, strategic opponents, experience management, and content generation. So what do I mean by that? And actually, it really goes back to the inception of the medium. In fact, the very first computer game, really, as we think about it, was actually a computerized version of the mathematical game of Nim from 1951. It's not a fun game. It's one of those mathematical games, so it's a game in theory rather than practice. It had a computer opponent in it, which is interesting because this is 4 years before the term artificial intelligence was normalized after the Dartmouth College event. The first, to my knowledge, I've done a bit of digging on this, I can't confirm this 100%, but to my knowledge, one of the first video games that actually had a computer opponent in it was Speed Race by Taito, which was an arcade game in 1974. Neither of these things are particularly smart, but they are systems that are designed to react to the player and try and create an interesting experience. And then subsequently, we started seeing this kick off in the 1980s. First with non-player characters as opponents become much more normalized rather than having games be a two-player experience where you actually go off against someone else. So the likes of Pac-Man helps normalize the idea of enemy opponents become a thing in games. And then games like Rogue, where content generation, procedural content generation algorithms are helping us to algorithmically build content in real time as you play it. Now, there was a big thing that happened in 1980 that led really to this kind of technological revolution. I appreciate the age range of this talk is quite broad, but can anyone guess what particularly was happening at that period of time in computing history that would lead to this sudden interest? Oh, my Discord is running. Any thoughts? Show of hands. Anyone older in the room that can remember? Yes, sir. Consoles. Home computing devices, absolutely. Until then, like we said, we looked at Speed Race. All the games that you were playing were in arcade machines. And so now we were moving into an era in which computing was coming into the house. In fact, my first computer was an Amstrad CPC 464 where you used to play games on tape. Anyway, moving past that one. So actually, really, when game devs think about AI, contrary to the narrative, we're usually thinking about classic game design problems. You're thinking about non-player character behavior. You're thinking of navigation problems. You're thinking of experience management problems, ensuring that the player always feels like they're part of the experience, that they're enjoying the experience, and they're having a good time. So actually, what emerged in the 90s into the 2000s was a term referred to as game AI, and this was a self-identification by game developers because in the world of artificial intelligence, this isn't really artificial intelligence. And it's really because when you think about it, what these games are trying to solve, and you think Doom through, I picked first-person shooters because first-person shooters were actually very influential in the development of game AI in the industry in the 90s and early 2000s. These are all catering to a very specific problem. In that when you're playing an AI in a game, it is trying to facilitate a theatrical experience, right? There are rules that are being set up by virtue of playing a game. When you're playing the game, you want the experience to be your experience. You're getting something out of this. You're able to tell your friends about this experience. And so there's rules being baked into that. There's rules baked into this talk. The idea that I'm going to be up here on the stage and I'm going to talk to you, you're going to listen, you're hopefully going to learn something out of this, but critically, my audience is here and the stage is here. And then I go and do something really weird. I apologize to whoever's trying to record this talk because now I'm no longer on the stage, but I'm trying to facilitate a point in that when this starts happening, the stage is moving, and critically, everybody turned their head. Most of you did. Some of you are like, God, what's this guy doing? Play to the rules of the talk. In games, the stage is always moving. And critically, actually, more importantly, the stage is moving because the audience is moving. As the player, you are moving around in the game, and so the stage always has to be where you're going and what you're interacting with to help keep that engaging. AI for games, or game AI specifically, isn't optimal, it's interesting. And that's often what differentiates it from a lot of AI you see in the rest of the world. Also, fun fact, can anyone figure out why I used Mario 3 specifically for this backdrop? Curtains? Not quite, almost. Anyone know? Anyone old enough to remember Mario 3? Yes? Say again? Yes, it was a play in the end. The Mario 3 is not canon. The entire game is a theatrical performance put on by the characters in the Mushroom Kingdom, which is why at the end of every level, you exit stage right. And Miyamoto-san actually confirmed that a couple of years ago. Mario 3 isn't canon. I love it. Anyway, and critically, when you think about game AI, even now, you look at kind of seminal games of the last 10 to 15 years, the Far Cry franchise, Middle-earth, Shadow of Mordor, and Shadow of War, Alien Isolation, BioShock Infinite, these all had interesting AI characters and systems. There wasn't a technological innovation. Most of the techniques that they use there are still the same they're using today. Fun fact, like the AI that was used in the original Doom is what's used in The Last of Us, the same core technology. Halo uses the same core behavior tech as the Spider-Man games, right? Like we've not really evolved in that space, but we find ways to innovate in design. And then equally, we've seen a kind of boom of procedural content generation once again in the last 15 years. because designers look to algorithmic content creation once again to find new opportunities. And these are, at the end of the day, and as we'll also hear from other speakers, these are intelligent systems that are being driven by expert knowledge baked into them by designers. So they are at their heart artificially intelligent systems, even if we very rarely talk about them in that specific context. So here we are. I've managed to go from, the 1950s to a couple of years ago, and I'm still talking just about this part of the diagram. What about the rest of it? And critically, also, if you're studying AI in any way, shape, or form these days, you're like, well, how has he not talked about machine learning like one bit so far? This is kind of weird. Well, machine learning for a lot of aspects of game development was considered a dead end for 30, 40 years, by and large, because it was. And I say this, I have a PhD in AI for games that I spent mostly studying machine learning to build non-player characters, and the thing I can tell you at the end of my PhD was don't do what I did, it was a waste of time. But machine learning, of course, to just kind of give a caveat, the big difference is that everything we've seen so far, we are baking our own knowledge into the system, and then the AI searches for solutions to the problem. Whereas machine learning, we train a model to learn rules that help us solve problems. We give it pictures of cats and dogs and teach it to identify what cats and dogs look like. And this is a big difference because once you now actually are in control of data and that's allowing you to build models, it actually allows you to capture nuances in the data that arguably it would be difficult for a human to encapsulate. And so this actually led to a big push into machine learning for games because we figured out, actually, what if we don't use it for the things that we use game AI for? What if we do something else with this technology? And when you hear about machine learning, you often hear about deep learning, which is a specific subset of this, which is really able of capturing these nuances of data in a way that allows us to build really meaningful and interesting systems. And if you've ever looked up deep learning in games, probably you've heard about Google DeepMind and the work that they've done in this space. First, having AI play a variety of Atari games. They had it play board games such as Go, and probably the pinnacle of this work in some regard is the creation of AlphaStar, which was a StarCraft bot that was able to achieve a Grandmaster status in the multiplayer community. These are really interesting, they're really exciting. They're also very bad examples of how this technology is used in the games industry. I don't really have time to get into this, but as cool as AlphaStar is, no game studio builds AI like AlphaStar. That is something that's really benefiting from the ecosystem that surrounds it. Ask me over coffee. Over the past decade, we've actually seen a silent revolution in games because we started figuring out, hey, what if we use that tech for different problems and solve different aspects of production that historically we couldn't do it in this way? So, for example, racing games. If you look at Forza's Drivatar system or you look at the Sophie system in Gran Turismo, these are both deep learning systems that evolve and learn off of data that they accumulate. Gran Turismo does it entirely by trying to learn good racing etiquette, whereas Forza does it by looking at how you play the game and then tries to mimic it. You have games like Madden, or it's not FIFA anymore, was it EA Sports FC or whatever? Sports games, these actually use, both of those games use what's called hypermotion, which is a specific machine learning library that figures out how to blend animations together so that when you see an athlete running on the pitch, it looks as smooth and as fluid as possible. And this is actually based on a technology called motion matching, which was originally introduced in Hitman Absolution in 2012, if I remember right. Nicely timed, Call of Duty Black Ops 6, I think, comes out today. If you're playing games like Call of Duty or Counter-Strike, there is now AI-driven toxicity and cheating systems baked into them. Call of Duty has a system called Ricochet, which is actually watching how people play the game and then trying to identify whether or not you're cheating as you play it. Similarly, games of this ilk, whether it's League of Legends, not League of Legends, Dota 2, and also pretty much any first-person shooter that runs in the Xbox ecosystem uses machine learning-driven matchmaking. You also have things like texture upscaling. So the Mass Effect Legendary Edition from a few years ago, the original Mass Effect trilogy ran at 720p on Xbox 360 and PS3, which by modern standards is archaic. When they wanted to upscale the entire thing to 4K resolution, they actually ran all the original textures through an upscaler, a generative adversarial network. I think it was at 3,500 textures or something they did, and then had humans go in and clean them up afterwards. And the idea was to cut down the amount of time spent on upscaling all these textures rather than doing it manually. Equally, God of War Ragnarok on the PlayStation 5 has a hidden neural upsampler in it. And in real time, it's upscaling all the textures, some of the textures in the game up to 4K. And one of the reasons they do it is to cut down the install size of the game on your PlayStation, because otherwise it would actually be about twice the size. And let's face it, most PS5 games, you can only put about 3 of them on the hard drive and then it's full anyway. Online games like For Honor and Rainbow Six Siege use deep learning to do play testing specifically for gameplay balance. So actually, Ubisoft repeatedly has bots sit and play tens of thousands of hours of For Honor on a weekly basis to identify issues within the meta of that game and then how to counteract it. And actually, they do exactly the same thing for Rainbow Six as well. And of course, any of you who has a laptop or a desktop with an NVIDIA GPU in it in the last few years may have tried out DLSS, Deep Learning Supersampling, which is a technology that is designed to upscale the output of a game in real time so that it's at a higher resolution on your monitor. All of these things are near impossible to do at the scale and complexity they're being done without the utilization of deep learning in this context. So, bringing it back to where I was, we've largely covered the diagram. And also have a look at there's a link here, which I'll also share at the end. I have a full blog and video which goes into this taxonomy in even more detail and points out to a bunch of other work that I've written about over the years. So, of course, in 2024, the conversation is all about generative AI. And this conversation is cloudy, I think, to say the least. A lot of people making proclamations about how generative AI will impact video games. And also, most of them don't actually come from the games industry. They're people trying to sell something to the games industry. And then the narrative is suggesting that within a couple of years, an indie will be able to write Elder Scrolls 6 entirely on their own instance of Unity. No. So for the rest of the talk, what I really want to do is give you an idea of where we are with this technology in games, because everyone's wondering, why isn't it in all our games already? And also just kind of do a little bit of myth busting as to what generative AI actually is. So generative AI is a form of machine learning that, unlike the other ones that we've done so far, we were capturing data to build rules to solve problems. With generative models, what we're doing is we're capturing data to understand the inherent underlying structure of the data. And then from that, you can build a statistical model that can reproduce the data at scale. So GPT, for example, if you ask it a question, if it's been trained on enough language, it can then reproduce an answer that sounds somewhat correct most of the time. Similarly, with image generators, you feed it enough images, it will eventually learn how to produce its own images. And these are technically impressive, and I think critically for someone like me who's been in AI for games for 20 years, the idea that we could get to a point where language models could generate this level of certainly creative writing, I think, is something that we did not think was even possible 10 years ago. Like, the growth in this space is astounding, and I think it's worth pointing out that there has been significant innovation here. But it's important to realize the quality of these systems is very much in the eye of the beholder. I hate the term hallucinations for large language models. Hallucination, if you've not heard this, is a term that says that a large language model will occasionally say something that's incorrect or invalid or irrelevant on a current topic. But a large language model is always hallucinating because the output is always in the eye of your perception of it. It just makes a statistically likely answer to the input you gave it. And then you go, oh, wow, that was correct. This thing's really smart, man. Well, yeah, that's because you decided it was smart. This is actually what we call the ELIZA effect. Go and look it up. We've been talking about this now for 60 years, where we have chatbots that we perceive to be smarter than they really are. Ultimately, these systems are generating the answer that is the most statistically likely. Just think of, like, a smartphone on steroids. Like autocorrect on your smartphone on steroids. Or actually, I often think of it as a mechanical parrot. So one of the things that actually makes these generative models really good is they scale up with the amount of data that you feed them, which historically wasn't really possible. And so subsequently, you've now got things like GPT, where if you feed it the entirety of the internet, it sounds almost human, which I think is actually a damning slight against the writing quality of most humans on the internet, but that's a separate talk. So I always think this is important to think about. Generative models are parrots because they can reproduce things at scale that they've heard before, but they don't inherently understand the things that you've taught them. I can ask it to draw me an image of a mechanical parrot. That looks like a parrot. That seems mechanical in nature, but it doesn't inherently understand that parrots only have 2 legs. And for some reason, this image has 3. And yeah, the games industry's really got in on this. Look at all these. These are all companies that apparently, I don't like these diagrams, by the way. This is some company that said, look at all these companies that are now building AI tools using generative models. Most of them don't use generative models, actually. In fact, I've worked for several of these that I know don't use generative models. This is what is called doing your research, and particularly if you're actually working in academia, cite your sources, man, because this person would get torn to pieces if we actually had them get this reviewed for an assessment. But we've got a whole bunch of different stuff in here. Dialogue and story generation, character creation systems, image and texture generators, animation generators, 3D model generators, voice synthesis, music generation. And I think there's a variety of quality here, but it's also leading to very significant problems and issues. There's huge risks. And also, critically, where's the data coming from that is used to build an awful lot of these systems? As we know, most of it is being taken from people without appropriate use, or there is risk that it's going to be exploited without the original author's permission. Hence, you have things like the SAG-AFTRA strike that's running right now, where motion capture performers and voice artists are striking against game studios who are not willing to give them protections against their data being exploited and utilized to full effect. So how is generative AI actually used in AAA, big budget video games? This is actually a question I get a lot from the press. Like, why isn't it all over games? Because we've seen it in everything else. Well, first of all, games take a long time to make. The average game, AAA game these days, 4 to 7 years, typically. They're also very expensive and notoriously risk-averse. So when you have a technology that isn't really trusted or fully fleshed out at this stage, putting it into the next Call of Duty seems a bit of a bad idea. But where are we? Mostly it's tech demos, really. On the left-hand side, this is a screenshot from Origins, which is built by a company called InWorld, that are building, large language models for story generation, dialogue generation, and also voice synthesis. That is a playable demo in Steam. You can go and download it for free, and you can go and chat with these characters as you try and solve a murder mystery. On the right-hand side, that is from NVIDIA's ACE platform, which is also being powered by InWorld's competitor called Convey. And these are both doing exactly the same thing, language models, voice synthesis, etc. You also see an awful lot of, that's the wrong direction, Tommy, spurious implementations, kind of flimsy implementations. I jumped ahead. The Finals, which is a free-to-play first-person shooter, the announcer voices in that are synthesized. They are entirely AI-driven, which strangely works for this game because they're supposed to be hokey game show hosts. And it's actually okay that they're not great because it kind of fits the narrative of the game. And then this is the generated art that was used in Foam Stars, which is a game that came out earlier this year, and I don't think I think I'm the only person still talking about Foam Stars at this stage of the year, another classic free-to-play game that has died within a very short period of time. Also, it was a Sony exclusive, so yeah, there's a bit of a track record there. Caution. You're not seeing any game go all in on using generative models. And there's a number of reasons for that, which it's all about risk. And we'll talk about that at the end of the talk in the next few slides. But every AAA company I work with or chat with is playing with this technology in some form or another. Think of a big video game company. Yeah, they've got a language model they're running internal in their studio. Yeah, they've got an image generator they're running internal in their studio. Yeah, they're figuring out whether or not they can use this as part of production, but are they putting it in their actual games? No. Why? Mostly because their legal team are going, absolutely not. You will bankrupt us. Do not do it. Interestingly, the most common application, and I've heard this now from both a technical director at a very popular MOBA creator and also a technical director, a senior producer, at probably one of the most famous MMOs ever built. They both use language models. I'm not saying which, because I'm pretty sure that's an NDA violation. They both use language models for lore. So if you think about games like this, you have hundreds of characters, you have thousands of years of backstory, and then you suddenly go, hang on, does that character know that character, and what's their relationship? One of the studios in particular, they told me they have a Slack channel exclusively for this, where someone says, hang on, do these two know each other, and how do they solve? because it isn't in the internal documents, it's not in their design documentation, it's not in the internal wiki, it's not even in the fan wiki that's available online. Nobody knows this piece of information. And they used to post this in a Slack, and then somebody would come forward and go, oh yeah, I was the prop artist on that character 7 years ago. Yeah, they hate each other. Why? We don't know, but we know they hate each other. And so one of the things they're trying to do is actually capture a lot of this information and put it into a language model, because one of the things that language models are very good at is summarizing existing knowledge. And so this way they've now got an internal lore LLM that's helping them figure out how all these different aspects of their lore so that they don't trip over themselves when they're building something new. But what about indies? Surely indies would be one of the big areas to push this forward. Yeah. Indie in inverted commas. Because of course, one of the things is that a lot of this technology is open source. You can go away and start building your own language models, image generators, etc. It's not as pervasive as even I would have thought. Naturally you have AI Dungeon, which is this one up here in the top, which has been around now since 2019, and that's a kind of choose your own adventure game that you can play on PC. Then more recently, we've got a lot of games that are trying to figure out how to use LLMs, but are struggling with the monetization aspect. 3 of them, the top left, that is Dead Meat, which is built here in the UK. 1001 Nights in the middle, that's also being built by a team here in the UK. And then Suck Up on the right. Each of these are trying to use LLMs for some aspect of play, where you actually interact with the LLM. Dead Meat, you're trying to solve a murder mystery. 1001 Nights, it's a retelling of that story, but you can use this, you actually tell the story and actually influence whether the king's going to kill you. And then Suck Up is you play as a vampire who's trying to convince the person at the door to let you in. Wonderful play on terms. Like my dad joke energy there, really love that. And also AI People, which I didn't put on this slide. That's essentially The Sims, but all the behaviors are being driven by LLMs. All these games have one problem in that they struggle with figuring out how to sell it. And in fact, they are also struggling to whether or not they can get on storefronts. Suck Up got banned from Steam, or they haven't even attempted to put it on Steam, and so they sell it outside of Steam with a subscription model. Also, critically, the 3 games there listed in gold, they're indie, but they're indies backed up by a multi-million-dollar AI startup, so the term indie, I feel, is very loose here. Anyway. Risks. I keep talking about risks. Let's get to the end. What's the big issue with generative AI and why are we not using it in games? Intellectual property. Yay! I've spent so much time reading up on law in the last year. This was not where I thought my career was headed. US and European laws do not allow for the attribution of copyright to anything generated by a generative AI system because essentially, as it is stated in the law, a human must have been involved in the creative process. And so as a result, if you were to build characters, storylines, entire game worlds through a generative system, you don't own it. And therefore, if your player base decides to steal, say you had a bunch of characters in an MMO, and then you have your player base decides to steal all the characters and put them in their own mobile game, you have no legal recourse to stop them from doing that. And there are entire game studios, well, actually there's entire legal teams at game studios, that's their full-time job, where they hunt down people doing cheap knockoffs using their characters and their intellectual property because they have to protect their trademark. So if you were to do that in a game, you can't really protect it anymore. And it's why a lot of games companies won't really utilize it. Hence, there's a big question of what's the line at which point a generated output can become copyrightable, and it's actually about how much a human begins to assert their influence on the output of the system. What the legal definition of that is shrug. We don't know. And so hence right now, all the lawyers are telling them, don't put it in the game. The other thing is what we call lot check. So if you've ever built a game, if you put a game on Steam, Epic Game Store, Xbox, PlayStation, Nintendo, you have to go through a process called lot check, where this is when the game actually gets checked against a series of guidelines and rules and regulations on whether or not it can be accepted to be published on that platform. I have went through lot check myself as an indie developer. It's not fun. The Xbox lot check guidelines is a document that is 58 pages long, and it points to another annex document which is also another 50 pages long. You want a good way to burn through a weekend? Yeah, print that out and read it. Good Lord. But right now, there's no guidelines outside of Steam on how generative AI can be accepted. And in fact, in an awful lot of them, if they know you're using generative AI, they ban it outright. Steam is the only one that's came forward with this And they now state that you have to be able to prove that generated assets do not violate copyright. And that critically, if you have live generated content, so say your game can generate avatars or emojis or text, story, dialogue, etc., it is not going to violate copyright, and it is also going to operate within the defined bounds of your age rating. So, hey, I've got a cute and cuddly game, and then suddenly this little Animal Crossing character starts cussing at me, quite extreme, while I'm on Twitch. That's a bad look. So Steam are actually now rolling out guidelines and reporting that can allow them to immediately report instances like this and have games like fast banned if it's found that they are violating this. Outside of everyone else, no clue. I think right now the Epic Games Store is you tweet Tim Sweeney and you ask him really nicely, and then your game gets on the platform. And actually the big thing right now is we actually have legislation. So earlier this year, the European Union signed the EU AI Act. It's the largest, most comprehensive regulatory framework on the adoption of artificial intelligence in the world. It's probably also going to be the strictest because the US, they don't tend to be as heavy-handed as the EU is. I say that, I actually really support what they've done with this. And the UK, whatever. Like, what we're going to do is going to be whatever the EU has dictated. And actually, critically, what we do doesn't matter anymore because this is a global business. And of course, we exist within the European area. And so now games companies are going to be looking at satisfying the EU AI Act because that's more important than satisfying whatever we come up with. Though admittedly, I'd like to think our new government can maybe do something a little bit stricter than what's been done before. And so this is actually having a huge impact critically because you cannot submit a system that violates copyright. You have to be able to show, if you build a certain AI model of a certain size, where the data comes from, how it was trained, what were the processes used for it. You have to be able to explain every aspect of this. And also, there is now compliance and training that is required for people who ever deploy an AI system within the European Union. This is taking a year or two to roll out. We're about 6 months in now, but it's going to have significant financial implications if companies do not come on board to this. Right now, what's really interesting about this is a lot of generative tools, most notably GPT, do not pass the guidelines for what is considered legal in the European Union in its current form. So there's a big question right now of whether GPT actually still exists in Europe in about 18 months' time, or they really try and sweet talk the government to try and get a deal. And I think probably the other thing is there's a huge amount of negative sentiment around this, and I think justifiably so. A lot of people's livelihoods are being stolen for the purposes of corporations trying to use it to exploit their own good. Critically, as I mentioned, SAG-AFTRA is currently striking against video game studios. Yeah, don't expect them to put GPT into the next Call of Duty anytime soon. Right, I appreciate I am pretty much over time at this point, but we'll do questions over coffee. Many of the topics I've talked about and the games I've talked about here, I've explored at great detail, as Mike says, on YouTube over the years. An awful lot of these are available on YouTube, but also on aiandgames.com, where I give a breakdown in written format as well. Thanks very much for your time. Thank you for listening. And yeah, I'll be around for the rest of this morning. Thank you. We got time? We got time. All right. Good. Who's got a question? Gentleman right there. Do you want this one?
Oh, we have a second mic. There you go.
Hi, Tommy. Thanks so much for the great talk. I'm really interested in discourse communities and specifically like attitudes around technology and how they develop. Have you noticed a significant kind of shift in the last decade of how, whether it's people you work with or commenters on your YouTube channel, about how the view towards AI in games and games design has shifted? And do you have any idea of where it's going to shift next?
Yeah, I think it really depends on where they are within the space. So I think on one hand, like I said, like the deep learning kind of revolution that's happened in game development has allowed for some really interesting, exciting applications that, like I said, a decade ago I would have thought impossible. I went to the AI and Games Summer School, which ran this year in Malta. It's going to be in Malmo in Sweden next year. If you're interested in going to a summer school on this stuff, go and check that out. There was an amazing talk from Ubisoft on how they're using machine learning to figure out how to do profiling of games on consoles without deploying it on consoles. Blew my mind. I thought this is one of the most amazing things. And so I find there's a certain community of people that are finding interesting practical problems that AI can help us solve, and they're still doing that. And I think critically that's where the generative stuff needs to evolve, because right now I think the dynamic in generative is you spend more time trying to tell a system it's wrong rather than it facilitating doing something correct. Equally, you've also got a lot of people in good old-fashioned game AI don't touch machine learning, will never touch machine learning, because it's not suited to the problem they're trying to solve. And I think it's important that they should be aware of these evolutions in technology, but some have put their line in the sand a long time ago. You're not going to be able to change those entrenched attitudes. The other thing outside of that is gamers and the general public we are now more aware than ever about AI technology, but equally we are increasingly more critical, I think, of AI technology. And one of the interesting, I talked about public backlash to this. One of the interesting things I'm now seeing on social media is people complaining about AI being used in game development, and they go, oh my God, I can't believe that they've now deployed, what was it? There was a whole thing recently about Final Fantasy VII Rebirth uses AI technology for facial animations, and it lip syncs. And someone was, oh my God, like people getting really angry on social media, go, I can't believe they're doing this. This is like, you know, a violation, and it's stealing jobs from people. It's like, they've been doing that since Final Fantasy 15. And this was something that came from the development team, because they went, this is a problem. It's a pain in the ass. Pardon my French. We don't like doing this. So they found a technological solution to a very, very difficult problem, to the point that it's increasingly normalized. Assassin's Creed uses this technology. Cyberpunk used this technology. A whole bunch of big AAA games use variations on this tech. But now we're having this interesting moment where, because the general public are becoming a little bit more literate about AI as a whole, they're being critical of the deployment of these technologies without really understanding whether or not this actually has value, and it's something that's came from the creatives looking to solve a problem rather than coming from management looking to solve creatives, if you get my meaning. But yeah, it's an interesting space.
Thanks so much.
Thank you. I'm afraid we're probably going to have to stop there,
That's
but
good.
As Tommy mentioned, we're going to have a coffee break in a minute, and there'll be plenty of time to chat then as well. Thank you so much, Tommy. Another round of applause for Tommy.